method of preparation of haloalkane is from alcohol. The general formula of alcohol is ROH. OH is hydroxyl group, or is hydrocarbon structure, hydrocarbon molecule, which may be a bigger, smaller, open chain, cyclic chain, but the hydroxyl group is connected to the carbon of the hydrocarbon like this. Hydroxyl group is bonded to carbon of the hydrocarbon, it may be of any structure. The reaction involves nucleophilic substitution. What is meant by nucleophilic substitution? Nucleophile is a negative radical like this. Here the bond breaks between carbon and O is unsymmetrical. Unsymmetric breaking of chemical bond. Both the electrons are towards this side becomes minus OH. This becomes plus or plus C. Now the X minus attack, that is the halogen nucleophile. This nucleophile is stronger than this, therefore can attack or replace. So that replacing one nucleophile by the other nucleophile is called nucleophilic substitution. So in place of which the halogen atoms comes. It is the nucleophilic substitution reactions. In the preparation of these compounds, let us see what are the reagents are used. The reagents or these reagents are using. There is a reagent that is concentrated HCl plus anhydrous zinc chloride. This is one reagent. This also called as glucose reagent. HBr, PCl5, Pb, PBr5, PCl3, PBr3, SO, Cl2. For making the halogen derivatives, we can use these reagents. This one, this one, this one, and this one. Chlorine compounds. For making bromo derivatives, we can use these reagents. This one, that is bromo compounds. For making hydro derivative, we can use, that is HI in place of this. That is PI5, PI3 like that, for making hydro derivative. So different reagents we are using for making different halogen derivatives. So let us take one by one some reactions, some examples of the reactions. Let us see what is the action of this reagent on the alcohol. That is the general formula of alcohol. The action of HCl, it requires what is our zinc. Zinc chloride acts as a catalyst. HCl acts as a reactant. Concentrated HCl. This is a reactant forming product like this. Replacing this by Cl. H2 is a byproduct. Let us see the mechanism. Here, this is using what is for making chloro-derivative. This you are using for bromo-derivative. Same reaction, almost same mechanism, HBr. But among the HBr and HCl, the difference we have here, it is less reactive, it is more reactive, because you see the reactivity difference of these compounds, the halogen derivatives of halogen. This is more reactive than this, which in turn more than this, more than this. So among these, this is more reactive than this. Therefore, HCl is less reactive, HBr is more reactive. So if we take HCl now, it is among the strength of the acid, this is stronger. There is stronger acid, this is little weaker than this. Now the point is this, if we take alone this without this, the reaction is not possible. That is why, because weak, that is less reactive, it requires some catalyst to promote the reaction, that is zinc chloride. Zinc chloride is what is Lewis acid, strong Lewis acid. So what is a Lewis acid? Is that Lewis means it is a proton donor or electron pair acceptor. Here electron pair acceptor. So that is why zinc chloride acts as a catalyst. Here doesn't require catalyst. Itself is strong, it can act on this and do the reaction. Now see the mechanism, what is the mechanism involved here? So it is not direct HCl acting on this. First zinc chloride acting on this. Look at the electronic structure of the molecule or hydroxyl group. There are two lone pair of electrons. So one of the lone pair form a bond, that is like a coordinating bond, just like coordination bond with the zinc, because strong Lewis acid acceptor, that is lone pair acceptor forming chemical bond. So with this chemical bond formation quite stronger, this bond naturally becomes weak. Now it is breaking will be easier for this formation of bond. So this forms readily with bonds. Now this bond begins to break, weak. Now with this breaking of this chemical bond, action of HCl will be easy. Now the bond becomes weaker by this activity. Now HCl begin to break like this, chemical bond minus plus. Cl act on this, H plus act on this. So it is taken away. What is that? After this chemical bond taken away as this minus. And then plus H forming H2O. Then this R Cl forming RCl. That is a mechanism. So Zn chloride, ZnCl2 is regenerated. These two are products. So act and regenerate, therefore act as a catalyst, but itself not consumed in the reaction. That is why zinc chloride will promote the reaction, will enhance the reaction, will support for the action of this on this, since it is weak. Now it is not weak, it is strong, doesn't require any reaction. So H plus can directly, what is that? Breaking a chemical bond as H plus and we are strong acid. H plus can act on this, what is that? Lone pair of electron forming a chemical bond. This plus move on to this by this action. So by this action, this chemical bond formation make this chemical bond weak. This chemical bond, what is that? Transfer is unsymmetric breaking. Plus becomes. Now this plus will acted upon by Br minus. This Br minus is generated after breaking a chemical bond. H plus will act, Br minus will act. So this bond breaks away with the action on this. This bond is broken away. This breaks and forming Br and H2O. So these electrons are taken. This one's H2O. So that is the product mechanism. So it doesn't require catalyst, it requires catalyst. That is mechanism. Let us see in more detail about the mechanism. Let us understand what type of carbon is present in the alcohol. Very important one. We need to discuss it. This carbon is what type? There are three different types we can expect. This is one, other one, other one. In this case, this carbon is connected to carbon, carbon, carbon. Here. It is called tertiary carbon, bonded to carbon, CH3, CH3, CH3. And any other, that is hydrocarbon molecule like this. This carbon is connected to carbon, carbon, but hydrogen. This carbon, only one carbon, these two are hydrogen. The difference, what is that? Of during the reaction, what is that? Mainly this bond is cleaving, that is plus and minus, becomes carbocation. So with the formation of carbocation, here this cation getting stabilized by the inductive effect. What is inductive effect? The bonding electrons, these bonding electrons, tapered electrons pushing towards carbon by the CH3 group. But H also pushing this, the bonding electrons. But that is what is that? The strength of the effect, inductive effect here less. What is that? The strength of pushing the electrons toward this is comparatively what is less than this. This is more inductive effect, it has less inductive effect. So here overall carbon, 3 carbon, more inductive effect because of what is that? Pushing the electrons closer to this can stabilize, because positive can stabilize the carbon atom much more. Here by 2 carbon but 1 hydrogen. The stability is less than this. Here the stability is even less than this, 2 hydrogen, 1 hydrogen. So these two are more stable, this is less stable comparatively. So this carbocation stability is reactivity or stability. that is more stable than this, than this. This is more than this is more than this. Stability order or reactivity order of the carbocation of the type, that is tertiary, secondary, primary. So now you have the mechanism in detail. See that what is the different mechanism it takes. If if carbon is 3 degree or 2 degree, that is carbocation is higher stability. What is the actual mechanism? So actual mechanism, that is the mechanism, the same mechanism, actual mechanism is here. First step is this. Bond is completely, what is that, dissociated, unsymmetrically broken, plus minus. So this is intermediate formation, carbocation like this. Intermediate formation. And next step is action of halogen, that is nucleophile on this. Plus and minus combine one new chemical bond. Second step. This step is ionic, fast. This step is slow reaction. There are two steps. This is a complex reaction. In kinetics, there are two complex reactions. Therefore, when you look at the kinetics of the reaction, when you look into the kinetics of the reaction, rate of reaction equals, look at the step and right, it is only one reactant is involved. Therefore, it is concentration of one, concentration, the other reactant has no concentration effect. That is, the reactivity is doesn't, it is highly reactive, the reactivity doesn't require concentration to the power of 0. So doesn't require, that is, the rate of reaction not depending on the concentration of this, but rate of reaction depends on the concentration of alcohol. Therefore, overall order of reaction is 1 plus 0 is equal to 1. First order reaction. So it is called as first order. 1 stands for first order. So SN1 means nucleophilic substitution of unimolecular reaction. So it is bimolecular nucleophilic substitution, unimolecular nucleophilic substitution, that is SN1, because its unimolecular is first order reaction. That is the case. If the same carbon is of the first order like this, that is primary carbon like this, what is the reactive mechanism? Mechanism that is not reactive, not much reactive, not much stable. Now the step of mechanism is different. Look at this. These two are reactants, HCl and HBr. Here no breaking of chemical bond into carbocation formation because it is not stable. Carbocation is not as stable as this. It is a simultaneous. What is that? Simultaneous breaking of chemical bonds in this reactant, in this reactant. This chemical bond is breaking. This H is forming new chemical bond is O, and this X is forming new chemical bond with R. Simultaneous chemical bond breaking, simultaneous chemical bond, new chemical bond formation. So as a result, we get the compound like this, a complex intermediate. So ROH. This bond begins to break, and the bond between this begins to break. That is bond no. That is dotted lines a weak bond. That is begins to break, and new chemical bond arise between this and this. Showing that. And new chemical bond arise between this and this. Overall, what is that? Are 4 chemical bonds. What is a partial state, not complete state, and that is intermediate, not this intermediate. First step. So this intermediate is called as activated complex or transition state. So this is a good example for what is that? Example for activated complex theory in kinetics. It is intermediate. Now, though this format is that, and the formation of this step is slow step. Next, this complex decomposed into products. Now, this chemical bond, what is that? Completely broken. This chemical bond is completely broken, forming H2 and RX formation. So this reaction is fast reaction. This step is fast reaction. Again, 2 steps. Here, first step. The steps are different. So accordingly, when you write the rate of reaction, here slow step, these 2 reactant molecules are involved. The activity of these two are important. Therefore, rate of reaction depends on the concentration of alcohol as well as HX to the power of 1 to the power of 1. The order of reaction is order of reaction with respect to these reactants. Total order is 2, 1 plus 1, 2, second order reaction. So 2 stands for this 2. Second order reaction or bimolecular nucleophile substitution. So that is the actual mechanism. So we have SN1 mechanism, SN2 mechanism. These mechanisms in organic chemistry are more often we see in the study. So what is a kind of SN1 mechanism? SN1 mechanism where you see in case of what is that? Carbon of this type, tertiary and secondary. Yes, SN2 mechanism we are finding in case of carbon of this type, primary carbon like this. That is one case. And another point to be discussed. In this, what is that SN1 mechanism, we get carbocation, that is completely bond broken. Here carbocation, 3 chemical bonds. One chemical bond is disappear. So other 3 reagents with these 3 chemical bonds remains. This chemical bond is disappear, that is broken, and it is detached. So when these 3 chemical bonds, there are 4 chemical bonds. The carbon is tetrahedral in structure. Geometry of the carbon like this with 4 chemical bonds, tetrahedral. So it is in spatial orientation in all directions. The spatial direction tetrahedral fashion, not planar or like this. But when one chemical bond disappear, only 3 chemical bond, it turns, the geometry of the molecules turns into a planar structure. That is, all the 3 chemical bonds in one plane. After the chemical bond is broken away, the sp cube, no, the unbonding orbital, that is p, because it backs to be p orbital like this. It is non-bonding, bond disappear, it is non-bonding p orbital without electron. The electron is taken away. So this, what is that in plane? This bond and this bond, this one plane. This is perpendicular to the plane. One lobe, p orbital above and below, the lobe above and below. That is the structure of the carbocation in this case. Now after the carbocation formation, the halogen, what is that? This nucleophile, that is plane now, in the other plane. So that is, it can attack, the nucleophile can attack now from this direction or in this direction, plane. Therefore, there are 2 possibilities, above the plane, below the plane. The halogen can attack forming chemical bond with this p orbital from this side. If it is formed with this, you get this configuration. Same configuration, OH on the same side, X on the same side. If the X minus attack the orbital from this side below, that is, so it is inverted. What is that? If this is attacked from the other side, we get this configuration. Actual initial configuration of this alcohol is this. If it is do so from this side, it becomes X. In the opposite side, substitution in the opposite side is substitution in the same side. So OH is this side, but X is in the opposite direction. OH is this side, X also, no, it's a replacement. That's exactly. So here geometry, what is that? Stereochemistry. I mean, what is that? The geometrical shape of the molecule. That is stereochemistry means there are 4 different groups which are directed in 4 different directions in the space. The arrangement of the 4 different groups in the space are different. So here it is inverted. What is it is retained? The geometry of the molecule is retained, but geometry of the molecule is reversed. Because of this, what is that? Entire geometry, that is, we see that the geometrical structures or stereochemistry of this carbon, it is retained, it is inverted. So it is called as racemic mixture. So in this forming, we are to get 2 different configurations two geometrical, what is the stereoisomers. So one is R and S. I'll tell you what is R and S in this example. So if one is R, other is S, 50-50 we get. We call racemic mixture. Two different stereoisomers we get in this case. Same compound, same molecular formula, but different configuration. That is stereo configuration. They are called as racemic mixture in case of SN1 mechanism. But in case of SN2 mechanism, what is that? It is the halogen is acting always from the rare side because it is not formation of carbocation. It is simultaneously. It is leaving group and attacking group. So attacking is only from the other side because it cannot attack from this side. Therefore, in this SN2 mechanism, it is complete inversion. That is, in SN2 mechanism, the geometry is completely inverted. If the reactant is R, product is S configuration. If the reactant, that is alcohol, is S configuration, halide is R configuration. Complete, what is 100% inversion in case of SN2 mechanism. There is a difference between SN1 and SN2 mechanism. Here, in case of SN1, we see racemic mixture. 50% of the same configuration, 50% of the reverse configuration. In SN2, complete inversion. That is, if alcohol is R, halide is S, and vice versa. So that is what. So see what is R and S configuration. If you say this is the carbon like this, we have four different groups. One in case of four different groups, the carbon, central carbon is known as chiral carbon. Chiral means carbon is connected to four different groups. It is called as asymmetric carbon as well as asymmetric carbon. Four different groups, H, OH, chiral carbon. So in this SN1 mechanism, here we have two products, that is the mixture, that is same configuration, OH, here reverse configuration, that is one, same molecule, reverse configuration. So this is known as S configuration, this is known as R configuration. On what basis you are calling as S configuration, R configuration? It is on the basis of you are assigning priorities of the group on the basis of atomic number. In define what is that? In writing the actual configuration, stereo configuration. So it is the halogen atom, atomic number, based on the atomic number, higher atomic number, higher priority. So atomic number, here higher priority, next is carbon with double bond here, next priority is carbon with this single bond, with all this adjacent bond. So it is higher priority, that is first priority, second priority, third priority, and last priority. So accordingly, you see that when you hold this bond, if you hold the back side of this, remaining three, what is that, which are oriented in three different directions of spatial, almost these two, what is that, positions are in the same plane, almost. If you hold the hydrogen like this, bond like this, and remaining what is oriented in directions, the groups are lying the same plane. So let us learn that order of priority, that is first order, the first, second and third. That is what, if you what is that, the goal is this is a order of priority, or what is that, that is a clockwise direction. Order of priority is what is that, anti-clockwise is called S configuration. If the order of priority in that case is anti-clockwise, it is S configuration. In this inverse, what is that, reverse configuration, same thing. If you hold the hydrogen atom backward and it here towards front side here, and these atoms, what is that, look at the configuration or priorities of these groups. This is higher priority, now this is the next priority that is priority from this, it is clockwise. So this clockwise priority is called as R configuration. So S configuration, R configuration means that is why we have different stereoisomers. So therefore racemic mixture, these two are racemic mixture in SN1 mechanism. Just to give an example to understand what is S configuration and or configuration. So that is the case. What is that? The need to understand the concept is what is SN1, difference between SN1 and SN2. SN1 we see in this case. SN2 we see only in this case. In SN1 we see racemic mixture. In SN2 complete inversion of the stereoisomer. That is the one. And last one, let us see, that is a glucose test. I said what is the reaction, the same reaction with the mechanism. After the reaction you get what is that? Halide, chloro derivative. If R is, that is tertiary, carbon is tertiary group, a white PPT appears, what is that, immediately, because it is more reactive, depends on the reactivity. The reactivity is more than this, it is more than this. Therefore, immediate formation of white PPT. But in case of second, reactivity decreases, but reaction takes place slowly. It is forming after 5 to 10 minutes. Slow rate. You can see the PPT formation between 5 to 10 minutes. If the carbon in the R is primary means we see no PPT because very less reactive. So just comparing the reactivity of the carbon using a glucose test, that is by no PPT or PPT after a long time or by heating, that we get that. So it is decided that glucose test is the one is to understand the reactivity of the carbon type or the type of the alcohol you have, that is primary alcohol, secondary alcohol, tertiary alcohol. So it can be distinguished. Glucose test is used to distinguish between different types of alcohols, that is primary alcohol, secondary alcohol. Same reagent. When you add this reagent and shake it well and see that if you get quickly, it is tertiary alcohol. If you get the PPT slowly, if no PPT or PPT after eating, it is primary alcohol. Very good test for what is that? Testing different types of alcohols is called glucose test. Thank you.